We've covered a lot here in Unit 3. So let's just kind of go back to the very beginning of it. We started out with dilutions. Yep. Thanks. So in a dilution, remember the biggest thing is if we're stated that we have a 2n11 dilution, we have to remember that that is 2 parts of our serum or concentrate in 11 total part solution. So when we are working with that, let's say that we want to know in a 2n11 dilution, let's say we want to find the ratio of serum to water. So if our ratio of serum to total is 2 to 11, what is our ratio of serum to water? We'll still have 2 parts serum. How many parts water is going to be in this solution? There's 11 total parts, and 2 of those parts are serum. How many parts are water? 9, perfect. So the ratio of serum to water is 2 to 9. If I ask to find the ratio of water to total, well, how many parts water are there? 9, and total parts is 11. So it's 9 to 11. So all 3 of those ratios are implied by that dilution ratio. And we might look at in a 3-in-8 dilution, how much water is needed to create 240 milliliters of solution. So we have again that dilution of 3-in-8. And if you recall, the 3 is the serum, the parts of the serum, and the 8 is the parts of the total solution. Well, looking up here in the problem, we have the 240 milliliters. Does that represent either one of those? $240 milliliters of solution, that represents the total solution. So now the bigger question is the amount of serum what we're looking for? No, we're looking for the amount of water. So here we can cross multiply and divide. 3 times 240 divided by 8, which is going to give us 90 milliliters. But that is the amount of serum. We want the amount of water, which can be found by doing 240 milliliters minus the 90 milliliters of serum, giving us 150 milliliters of water, or NS. The other way we could have approached that is we could have redone the ratio. Instead of 3 out of 8 is serum, 5 out of 8 is the water. Then we could have done the 240 milliliters and cross multiplied divided. We would have got the 150 milliliters for the water again. Or we might have in a 1-in-7 dilution, how much, let's say ammonia, and how much sterile water are needed to create 350 milliliters of solution. So we have that 1 in 7 dilution. And remember, the 1 represents the serum, in this case the ammonia, and the 7 represents the total solution. Up top here, do we have a number that represents either one of those? Well, the 350 represents what? Total solution. Good. 350 milliliters. So now we're going to cross multiply and divide. 1 times 350 divided by 7 gives us 50 milliliters. That's the amount of ammonia. To find the amount of water, we could redo our ratio and do 6/7. Figure out how much that's going to be out of the total of 350. We cross multiply and divide there. 6 times 350 divided by 7 is going to be 300 milliliters. Or we could have just did the 350 minus the 50 to get 300, but we now know that we need 50 milliliters of ammonia and 300 milliliters of sterile water, of NS. One of the next things we looked at was solution concentrations. If we have 17% weight in volume solution, now remember, in a weight in volume solution, the weight is given in grams and the volume is given in milliliters. So how much, let's put in lepticin is needed to create, let's just do 300 milliliters of solution. So 17% is 17 out of 100. And because this is weight in volume, the 17 represents grams and the 100 represents milliliters, as we said. So on the other side here, we have the 300 milliliters of total solution. Well, there's 2 things that tip us off as to where that needs to go. 1, it's in milliliters. 2, it's 300 is the total solution. That represents the same as the 100 and the percent does. So the units up here are going to be grams, so they match up. 17 times 300 divided by 100 is 51 grams. It requires 51 grams to create that solution. Let's say what volume of, let's do an 8% volume in volume solution can be created with 20 milliliters of serum. So 8% volume in volume means 8% means 8 out of 100, and the units on both of those, volume and volume, will be volume units, milliliters. And here what can be created with 20 milliliters of serum? The 8 represents the serum, so the 20 milliliters of serum has to go on top, and we'll cross, multiply, and divide. So 100 times 200 divided by 8 creates 250 milliliters of solution. So there's not a whole lot we can do with those. One of the next things we looked at is we looked at that concentration adjustment formula, or change of concentration formula. And that change of concentration formula was C1 times V1, the first concentration times the first volume, is going to equal the C2 times V2, the final concentration times the final volume. As long as all we add to this is water or neutral solution, something with no medicinal value. So this saves us a lot of work. We did some of this with our dilutions earlier, and this saved us a lot of work having to go through all the steps of dilution. So let's say that we have 240 milliliters of 18% solution is diluted to 600 milliliters. Find the new concentration. So here the original volume and concentration is the 240 and the 100 and the 18. So 18, again, I can either change it to a decimal of 0.18, or I can just leave it as a percent as 18. I'm going to choose to just leave it as 18 times my volume of 240. Now on the other side, I am looking for that new concentration, C2. I have my volume of 600. So now I'm going to go ahead and multiply 18 times 240, which gives us 4,320. And then we solve for C2 by dividing by the 600. And we get 7.2. So that new concentration is 7.2%. There are a lot of other applications for that. We might ask, let's do 120 milliliters of 30% solution is diluted with let's do 240 milliliters of NS. So we want to find the new concentration. So this is very similar to the last one with one little twist. We're not given the new volume. Now we have the original concentration volume is the 30% times the 120 milliliters. We are looking for the new concentration, so C2. But that new volume is the original 120 milliliters plus the 240 milliliters that was added to it. So we'll multiply 30 times 120 here is 3,600. Over here, 120 plus 240 is 360. And we divide by 360 to solve for C2. So 10 equals C2, so that is 10% is our new concentration. We do this in reverse order. We could ask, how much NS is needed to dilute 300 milliliters of 45% solution down to 20%. So again, we have 300 milliliters of 45% solution. That's where we're starting out here. So 45 times 300. We want our new concentration to be 20%. We are looking for V2, that final volume. So 45 times 300 is 13,500. Equals 20 times V2. And we'll divide by the 20. So what do we get? 6,750 equals V2. Does that look right? Yeah, the extra zero. 675 should be V2. There we go. That looks better. So 675 milliliters is the new volume, but that doesn't answer the question. We're asked how much NS needs to be added to dilute this solution. Well, we had 300 milliliters before. We need a total of 675 milliliters. So that difference is what has to be made up with the neutral solution. So we need to add 375 milliliters of that saline or neutral solution to dilute that down to 20%. So we can do a lot. Those are all variations or offshoots of those dilutions. One of the other things, of course, we can do with it is we can adjust the concentration. Let's say a 48% solution is put through a 3-in-8 dilution. Find the new concentration. And what we found here was that we can actually just take the percent, the 48%, and we can put it in a ratio with our dilution. Because after being diluted, we know it's going to be a smaller percent. So the 48 has to go on bottom with the larger number in the dilution. 3 times 48 divided by 8 is going to give us 18%. The new solution, the new concentration is going to be 18%. The other way that could be done is we could have just taken our 48% times that dilution of 3 and 8 times this 3/8 as a fraction. Would also have given us the 48%. Kind of the big kahuna, the big challenge with our dilutions was problems where we're doing blood testing or urine testing. So if we have that sample that exceeds the meter, we're going to dilute 80 micrograms, microliters we'll put in, make it a little easier on ourselves, microliters of blood with 200 microliters of sterile water, of NS. The new reading after we dilute it is 340 milligrams per deciliter. We want to find the true reading. So here our first step is to figure out what the dilution is that's used. So our dilution here, we have, remember dilution is serum or concentrate over total volume. So in this case, the serum is our blood. How much blood did we have? 80 microliters, perfect. The total solution. How do we find the total volume? It's not going to be just the 200. We're going to find it by doing what? There we go. 200 plus the 80, or 80 plus the 200 microliters. So that gives us 80. The microliters are going to cancel out. It gives us 80 over 280. Both of those divide out by 40. Gives us a 2 and 7 dilution. So that's our dilution. And once we have that dilution, we can now adjust the meter reading. The 340 is going to go on bottom because that's the larger. Oops, sorry, the 340 doesn't go on bottom. The 340 goes on top because we would expect that to be the smaller number compared to the actual reading. And now we'll cross multiply and divide. 7 times 340 divided by 2. Oops, that didn't work. Yeah.
Where did you get the 40 from?
Good question. I'm looking at, this is just a fraction of 80 over 280. Both of them can be divided by 40. I could have done like 80 over 280. I could have said, hey, they both end in 0, so I can divide by 10. That'd give me 8 over 28. And say, oh, well, they can still both be divided by 4, so let's divide them by 4, which would give me 2 over 7. So all I'm really doing there is reducing the fraction. You bet. So we cross multiply and divide here. 7 times 340 divided by 2 gives us 1,190. And that unit is going to be milligrams per deciliter. So the true reading is 1190 milligrams per deciliter. And this is something that does come up in practice. Not a lot, because that would mean there'd be a lot of people that were really in rough shape. But it does come up in practice enough to make it worthy of knowing how to do. Okay. As far as loading the syringes and reading the scales on the syringes, I'm not going to have that on our test. It's something that's good to know, being able to interpret those scales. Like if you want to read the nomogram for body surface area, you'd have to still be able to interpret those scales. So it's a skill that's it's very important, but trying to test it on the test, I kind of decided it was easier to assess other things on the test than that, and I had to leave something off to keep it from getting too long. So that's what I've chosen to leave off. But we do still need to be able to calculate the dosages and look at those dosages. So if we have, let's start looking at basic dosage calculation. So if you have a doctor's orders that are for 80 milligrams of a medication, and on the label it says 5 milligrams and 2 milliliters. To figure out what to administer to our patient, we always start out with the doctor's orders. Make it into a fraction by putting it over 1, so 80 milligrams over 1. And we're basically doing a unit conversion to get to our on-hand dose. The milliliters is our on-hand dose. That's what we're going to be able to, or sorry, the milligrams is our on-hand dose. We're trying to get to the vehicle that carries it to the patient, which is the milliliters. So we're going to put 5 milligrams relates to 2 milliliters. So 5 milligrams goes on bottom, 2 milliliters on top. The milligrams cancel out. 80 times 2 milliliters is 160 milliliters. And 1 times 5 is 5. We divide that out to get our final answer of 32 milliliters. So we would administer 32 milliliters of that medication to the patient. We might have orders for 2,000 milligrams of medication to be given to the patient. And our label on the bottle is, this comes in 600 milligram tablets. And I'm going to give their scored tablets. And of course, what does scored mean? That means they're marked so we can break them in half. So that means we are going to round to the nearest half a tablet. So let's go ahead and see what we come up with here. We have our 2,000 milligrams ordered. Put that over 1. We're going to get rid of the milligrams. 600 milligram tablets, so we're going to tablets. So 600 milligrams is equivalent to 1 tablet. The milligrams cancel. 2,000 times 1 tablet is 2,000 tablets. 1 times 600 is 600. We divide that out. 2,000 divided by 600 is 3.33, or 3 1/3 tablets. Now we want to get this, we want to round, as we said, to the nearest half a tablet. 3 1/3, or 3.33, we're looking at it on a number line, is between 3 and 3.5. So the question is, which is it closer to? Well, remember, 3.5 is 3.5. This is 3.3, somewhere in here. So it is definitely closest to 3.5. So that's going to go down as 3 1/2 tablets for that patient. Then we might look at IV flow rates. We might have find the flow rate for 230 milliliters infused over 20 minutes. Now we need to know whether this is milliliters per minute, milliliters per hour, drops per minute. So we find that this is giving us the units we're asked for as milliliters per hour. So right now we have 230 milliliters over 20 minutes. We have to convert minutes to hours. So we'll put minutes on top, so they'll cancel out. Going to hours, 1 hour is 60 minutes. So those cancel. Now I'm going to cross cancel here just to make this easier on myself. 20 and 60 both divide by 20. 20 divided by 20 is 1. 60 divided by 20 is 3. So 230 milliliters times 3 is 690 milliliters. 1 times 1 hour is 1 hour. And that's what we want. We want the denominator to be 1 hour. So that is 690 milliliters per hour. If this wasn't 1, we would just divide out by whatever that number was. For example, let's say that we are going to infuse 800 milliliters over 5 hours. And again, we're asked for that flow rate in milliliters per hour. So we write it as a rate, 800 milliliters over 5 hours. Well, all we need to do here, it's already in milliliters over hours, we just have to make it a unit rate. So the number in the denominator is 5, we're going to divide both numbers by 5. So that cancels out to give us 1 hour on bottom. 800 divided by 5 is 16 milliliters on top. Sorry, 160 milliliters on top. That's 160 milliliters per hour is our flow rate. Well, those flow rates can get a little more complicated. We can start converting to milliliters per minute instead of milliliters per hour. So let's say that we have orders is to infuse 600 milliliters over 4 hours. And our label gives us a drop factor of 15 drops per milliliter. This time we're going drops per minute. Now I mentioned milliliters per minute. We'll get to that here in just a second. So we have 600 milliliters over 4 hours is our order. First step we have to do is we do have to get rid of the hours. 1 hour is 60 minutes. So I cancel out my hours. Now I'm going to do some cross canceling here again. I have the 60 and the 600. Both can divide by 60. 60 divided by 60 is 1. 600 divided by 60 is 10. So 10 times 1, 10 milliliters times 1 is 10 milliliters. 4 times 1 minute is 4 minutes. If I wanted to here, I could divide that out. 10 divided by 4 is 2.5 milliliters per minute. So if I were asked for this in milliliters per minute, that would be my answer. Here, though, I want drops per minute. So I'm going to have to take that 2.5 milliliters over 1 minute. I'm going to have to keep going. 15 drops per milliliter. Now, get rid of milliliters. Milliliters are going to go on bottom. Drops on top. 15 drops per 1 milliliter. So the milliliters are gone. Now I have drops on top and minutes on bottom, which is what I want. Drops on top and minutes on bottom. 2.5 times 15 is 37.5 drops. 1 minute times 1 is 1 minute. So our answer here, we said depending on whether we're using an electronic infuser or a manual infuser, sometimes we would round to the nearest drop, sometimes we'd round to the 10th. We're going to assume here that this is an electronic infuser, so we are going to round to the nearest 10th. So we'll leave that as 37.5 drops per minute. Well, with those IV flow rates, there are a lot of other things that we can consider. For example, let's say doctor orders 2 liters to be infused over 5 hours. And we have a drop factor of, I did this backwards, but that's okay. We'll do this example anyway. 20 drops per milliliter. Get that to work out. Let's find the flow rate, and we'll find our flow rate in drops per minute again. So I'm going to do some changing as I write this out. 2 liters is 2,000 milliliters over 5 hours. And I'm going to do this all as one big piece instead of breaking up. I broke that last one up because I wanted to do the milliliters per minute before I got the drops per minute. Here I'm going to break up the hours first. 1 hour is 60 minutes. The hours are gone. And then I am going to get rid of the milliliters. We have the drop factor of 20 drops per 1 milliliter. So our milliliters are gone. So now we have drops on top, minutes on bottom, which is what we want. Drops on top, minutes on bottom. So we have 2,000 times 1 times 20 drops is 40,000 drops. Over 5 times 60 minutes times 1 is 300 minutes. So 40,000 divided by 300 is 133.33. So we're going to go to 1 decimal place. 133.3 drops per minute. Let's look at the infusion time. It's kind of what I was trying to get to with that last example, but I messed it up. Let's say our flow rate is flowing at 40 drops per minute. We have a drop factor of 20 drops per milliliter. I want to know how long will it take to infuse 6,000 milliliters. So now we are going to start with the 6,000 milliliters, and we're going to convert it into time. So 6,000 milliliters over 1. So we need something with milliliters on bottom. Well, we have our 20 drops per milliliter. Drops per 1 milliliter. So milliliters are gone. We're now in drops. Well, we want to get rid of drops. So we've got drops per minute here. 40 drops would go on bottom per 1 minute. And we see that the drops have now canceled out and we're left with minutes. So this is going to give us our time in minutes. So we've got 6,000, times 20 is 120,000 minutes. 1 times 1 times 40 is 40. So 120,000 minutes divided by 40 is 3,000 minutes. Let's convert that into hours. One hour is 60 minutes. 3,000. The minutes cancel. Let's just do that. Minutes cancel. We got 3,000 hours over 60. That divides out to be 50 hours. So at that rate, it would take 50 hours to infuse 6,000 milliliters. So those are our IV flow rates. Now the next thing we look at is we got to look at dosages based on weight, and body surface area, and they might vary. They might be given in just a single number or a range. So we might be given something like the doctor might just order us to do. I'm trying to think of a good example. Let's say it's 4 milligrams to 6 milligrams per kilogram every 8 hours. And the doctor orders just to administer the recommended dose, but wants it administered every 6 hours. For a patient that weighs, let's make them 121 pounds. So our first step is to turn that patient into kilograms. We divide by 2.2, which is going to give us, I believe it should be 55, and yes it is, 55 kilograms. So that's where we're going to start. So now we're going to get a range here. We're going to get a minimum and a maximum. So let's start out with one of the two numbers. I'm just going to pick the 4 milligrams per milliliter. We're going to start with the minimum. So this is 55 kilograms. We're going to put it over 1. Kilograms are going to go on bottom here. So it's 4 milligrams per 1 kilogram. Kilograms cancel out. That's going to give us 220 milligrams over 1. But we have to remember that is per 8 hours. The doctor wants us to administer every 6 hours. So we're going to take that 220 milligrams and we're going to do a titration. That's figured for 8 hours. We want to figure it for 6 hours. So 220 times 6 divided by 8 is going to be 165 milligrams. So that's going to be 165 milligrams every 6 hours. That's our minimum. To find our maximum, we do another titration. Use that 165 milligrams. And up here we had 4 to 6 milligrams was our recommended. We used the 4, so that goes on bottom. And we're going to 6. So we have that 165 times 6 divided by 4 gives us 247.5 milligrams. That's still in 6 hours. Is our maximum dose. So that is the range that would be recommended dosage for that patient. Now we just have a couple minutes left. So a couple of things I want to warn you about to be careful of. Let's say that we give you, sometimes the tendency of students has been to read too much into some of these questions. So let's say the doctor orders GRIX of a medication. What that is stating, remember, GR is grains, and IX is Roman numerals. IX is 9. So that's 9 grains is what the doctor has ordered. So we might have a label that says, 15 milligrams in 4 milliliters. We need to know how many milliliters to administer to a patient. Well, our first step is going to be to convert that 9 grains into milligrams. And we know that 1 grain is 60 milligrams. So now the grains are gone and we are in milligrams. And now we have 15 milligrams per 4 milliliters. So the milligrams are gone. We are now milliliters, and this will give us our calculation for the amount to administer. I'm going to cross cancel the 15 and the 60. 15 divided by 15 is 1. 60 divided by 15 is 4. So we got 9 times 4 is 36. Times 4 is 144 milliliters. So be careful with some of those that have hidden conversions in them. Those are the ones that most people that are most missed on this test. Okay, with that, there is no new homework. It is just on Friday. It is our test 3. You will have the whole hour. Plus, you get up to 2 hours for these tests. This is one that a lot of people do need additional time for. We'll just take the 1 class period on Friday for it. So if you need more time, you can arrange it at your location. You guys have a great day, and we'll see you on Friday.